Welcome to Spring Lib.
Essentially be the roller coaster. I have just labeled some relative maxima, and relative minima. And here at point A, we have the maximum potential energy. And at point B, we have the maximum kinetic energy. Now, with that kinetic energy, we can move all the way back up to point C, which point C has a little bit less kinetic energy than point A. So we can say the potential energy at C is a little bit less than the potential energy at A. Rather, it really just depends on this height right here. And then at point D, we know that the kinetic energy at D is a little bit less than the kinetic energy at B. And this is only because at point D, we're not as low as point B. And so some of the potential energy at point D, at point C, hasn't all been converted to kinetic energy at point D. And then we can say that also the potential energy at C is approximately equal to the potential energy uh, at point E, but this is also a little bit less than the potential energy at A. And this is simply just the roller coaster car and the roller coaster tracks. All of that and sound energy, thermal energy, all of that, those types of energies will essentially make it so that you will not be able to ever, once you drop from height A, from point A, you won't be able to ever obtain that same height because some energy is actually being lost to, again, sound energy, thermal energy, and work. Some work is being done by friction between the roller coaster car and the roller coaster tracks. And so again, you will never be able to reach that height, and you will reach very close to that height, but again, the potential energy at point C is a little bit less than the potential energy at point A. That is the end of the solution. Thank you for watching.